You're loading.
Yep.
Yeah, I can see him.
All right, we'll get cracking. Okay, so today we're going to talk about selection of chillers. We've talked about the air-cooled and water-cooled chillers, but now it's a few of the factors to consider, or it's not everything, but it's the main things to consider when you're looking at selecting chillers. So as we've discussed in previous sessions, water chillers, or sometimes called refrigeration machines, are commonly used in HVAC systems as the primary cooling source. Chilled water is produced in the chiller and circulated throughout the chilled water system to cooling coils in air handling units, fan coil units, and maybe other process items. Like in a laboratory, there might be machines that use chilled water for cooling. In that situation, you may use the central chiller, or you might have a separate dedicated chiller just for those items. Another one is in hospitals where you say an MRI machine, for instance, often needs chilled water for cooling. Sorry, Hudson, just before I go, did you start recording?
I did, yeah.
Oh, sorry, I forgot to ask. Thanks.
All good.
Yeah, MRI machines usually need chilled water for cooling, but sometimes they have separate chillers for those. So we'll just go through some of the factors to consider when selecting a chiller. Obviously, number one is the total cooling load for the project, calculated using CAML or a similar heat load program, and include appropriate safety factors and diversity, if that's applicable. So a lot of different projects will have different diversity levels. Hospitals don't have much diversity because they're running 24 hours a day, and most apartments are operational. Morning, Stephen.
Good morning.
But a hotel, for instance, there may be a fair degree of diversity there because people, during the hot part of the day, the guests of the hotel generally may not be there. They're out exploring or attending meetings or whatever they're there for. So those things have to be considered, and it's not always easy to work out that diversity. Make provision for future expansion or changes in the cooling load. So, if you're aware that there is going to be additions to the project in the future, make sure that you allow for that in the selection of the chiller and design of the system. Chiller heat rejection, spatial provisions, and power supply. So we've got air-cooled versus water-cooled. Which way are we going to go? Air-cooled chillers are typically easier to install and require less maintenance, but they have less energy efficiency than a water-cooled chiller. So that's always important, but may not be the governing factor for the selection. Air-cooled chillers are also typically very large compared to water-cooled. So an air-cooled chiller, we've talked before about this, generally can get capacities up to about 1,500 kilowatts. Above that, if you're using air-cooled, you'll have multiple chillers. A 1,500 kilowatt chiller is roughly 15 metres long, okay? About 2 metres wide, 2.2, and probably about 2.2 to 2.4 metres high. So it's a big piece of kit. 1,500 kilowatt water-cooled chiller is probably only a few metres long. So that's something to bear in mind. The water-cooled chillers require a cooling tower or a fluid cooler or hybrid cooler, and significantly more water management and maintenance. So there's pros and cons for all these selections. When considering air-cooled chillers, ensure there's sufficient space on the roof or the ground to locate the chillers. So as I said, they can be very large, so you need a fair bit of space. And this is often a limiting factor. Also ensure that there's sufficient clearance around the chillers to enable satisfactory heat rejection to the ambient air. So the air's got to get in and out of the condenser to be able to reject the heat. Sometimes the building designer or architect will want to hide the chiller in an enclosure on the roof or with walls all around it. So you just need to make sure that you comply with the clearance requirements of the suppliers, and make sure they're going to work satisfactorily. If you're considering water-cooled chillers, an internal plant room is required for the chillers, pumps, etc., as well as roof space for the cooling towers. Typically, the chiller is located in a plant room within the building. You can build an enclosure on the roof if you haven't got a plant room available and you want to use a water-cooled chiller. You could put it into an enclosure on the roof. You know, it's an option, but it's very rare to do that. I have seen it done. You know, it's certainly an option. And the roof space required for cooling towers is normally much less than that required for air-cooled chillers. Another factor to consider, talking about dimensional things, is the weight of the chillers. Ensure that the building structure is capable of supporting the chillers. Now, this sounds like, you know, well, the building should be fine, but, you know, this is important to make sure that the building designers and the builder themselves are aware of the weights. They'll normally ask for that anyway, so that the equipment can be accommodated in the proposed location. Like a long time ago, actually about 40 years ago, in fact, I worked on a big project, a hotel project with casino, convention centre and so on. We had 4 quite large centrifugal water-cooled chillers in a plant room. And the plant room floor was actually suspended. And somewhere along the line, the communication must have failed, or the structural strength wasn't provided that it should have been. And the floor actually collapsed. Fortunately, the chillers didn't fall through the floor, but we had to take one chiller out. There was only really one chiller that was affected by it, and the floor just sort of caved in a bit. So the chiller tipped over, didn't fall over, just tipped forward. We had to remove the chiller and bolster up the floor and put it back again. So, you know, it's important to it's an important consideration. If a chiller is being added to an existing building or project with an existing water-cooled system, the new chiller would obviously normally be water-cooled. You add that onto the system, provided you've got enough heat rejection capacity in the condenser water system. If you don't, then you might need more cooling towers, more fluid coolers to accommodate the extra chiller. And then the spatial requirements comes in again. Ensure that the selected chillers meet or exceed statutory energy efficiency requirements, i.e. the NCC and MEPS. Generally they will, but if you're using reputable manufacturers, they'll be designed and manufactured to suit those requirements, but you need to make sure they do. Higher efficiency chillers may have a higher initial cost. You don't get something for nothing, so if you're getting higher efficiency, it's going to cost some more money. But they can provide significant energy and cost savings over time. Some projects, and existing projects, have limited electrical power capacity. You might come across this situation. In this case, water-cooled chillers may be the preferred or only option in order to achieve the project cooling capacity within the constraints of available power. Now, that probably sounds like a bit of a silly thing to say, but it does happen. It mightn't happen very often, but you might find during your working life that this comes up. They say, oh, we've only got 400 amps. What can we do? So you might find that a water-cooled chiller will do the job. And there'll be probably a higher cost for the job, but it will do the job. And further considerations include whether the chillers are required to be cooling only or heat pump type cooling or heating, which is now very popular, or 4-pipe type simultaneous cooling and heating. The 4-pipe chillers are typically air-cooled. Now, delivery lead time. This is another important thing to be aware of. Chillers are selected from a standard range, so you'll look up the data for the what's offered standard range of chiller, but they're normally manufactured to your order. So if you want to order a chiller, they won't have one sitting around waiting for you. They'll have to make it. Depending on the size of the chiller and the manufacturing location, the lead time can be as high as 4 to 5 months. Okay. So that's important when you start a project. That selection of the chillers is often the major priority to ensure that the project program can be achieved. So when you start a job, probably the first thing you need to look at is what chillers are we going to use and what's the delivery time. Now, when I say 4 to 5 months, I'm referring probably more to the large water-cooled centrifugal chillers. They all come from overseas. The first thing you'll have to do is make sure that all the selection criteria is correct and it complies with the documents you've been given. And then go through the process of talking to suppliers, getting the best deal you can, and then getting it on order. So that takes a bit of time. I mean, that process, just doing that negotiation and checking, might take you 2 or 3 weeks. And then you've got another 4 to 5 months delivery time. So always keep that in your mind that you need to sort that out quickly. Some suppliers will hold chillers in stock for quick delivery to fast-moving or smaller projects. This can be quite handy. Typically, the stock chillers range in capacity up to a maximum of around 400 kilowatts. And they might be screw chillers. Now, they do have a variety, but normally air-cooled chillers up to 400 kilowatts, screw or scroll, because for the suppliers, the local suppliers who have to hold these in stock, they don't want to spend too much money to purchase the stock. So it's going to be the cheapest sort of chillers. As I said, it's not economical for them to hold a stock of larger chillers because they probably won't suit what you want anyway. Site access for installation. Part of the chiller selection process includes evaluation of access for delivery and installation of the chillers. This may affect the time frame of the project as well. For example, if air-cooled chillers are to be installed on the roof, they can't be installed until the roof construction is completed. So in this case, delivery time of the chillers may not be critical, but completion of the project will be dependent on when the chillers arrive and get installed. So this also applies to cooling towers if they're to be installed on the roof. Following installation of the roof-mounted equipment, there is still a significant amount of work to complete, including the pumps, pipework, wiring and controls, etc. And then all the commissioning. Ensure that there's access and provision for hoisting the equipment into position. And sometimes, a new building will have a site crane, which may or may not be available when the chillers have to be installed. And I know builders generally want to get the tower cranes off the project as soon as they can because they cost money. And so if you're not ready to get the chillers up there as soon as the roof is ready, they might pull the crane down. I've seen this happen too. So I'm just giving you a few little things to be careful of. Make sure that everything's ready. If they take the tower crane down, you'll need a mobile crane. And that mobile crane needs access to the site and a suitable position to set up on site to carry out the hoisting. The mobile cranes are a bit limited on how high they can lift as well. So just some other things to think about. Depending on the plant room location and delivery time of water-cooled chillers, access may be required inside the building for horizontal movement of the chillers into the plant room. A lot of these things are based on my experiences over the years. We did a hospital job once where we had a very large hospital, large horizontal floor plate, about 4,000 square metres on each floor. And the chillers were sort of in the central plant room. So we had to land the chillers on the outside of the building and then skate them through the building to the plant room. And that's quite a task, or it can be. So another thing to be aware of. Now, compressor types. There are various types of compressors available. And then selection will be driven typically by the capacity, the efficiency required, and the cost. As I said before, efficiency and cost go together. If you increase the efficiency, normally you're going to push the cost up and you're going to go to a different compressor type. So the most common types are centrifugal, can be hermetic, open drive, magnetic bearings, generally the most efficient and suitable for medium-sized to large projects, and typically the highest cost. So we'll just have a look at some examples of that. It's the water-cooled chiller with a centrifugal compressor. It's a bit hard to see the compressor. It's sitting up there. I've got some better pictures of that. This is a cutaway of a train centrifugal compressor. So this is a suction pipe here, the compressor's in here, and this is the motor. So that's a hermetic type motor because the refrigerant passes through the motor as well. And that's the train compressor, not cut away. So you got the evaporator down here and so on, evaporator, condenser. So they're generally quite large chillers. And you've got the, typically centrifugal chillers will be the highest cost. The next lower cost option, and it's a less efficient chiller, is the helical rotary or screw type machine. Less efficient, generally suitable for small to medium-sized projects. It can be air-cooled or water-cooled, and typically lower cost than centrifugal. So let's have a look at one of those. That's a screw chiller, water-cooled, got an evaporator and a condenser. And that's the screw. I've got a picture of a screw somewhere here. Screw compressor. This is actually an air compressor, but it's the same principle. You've got two helical screws working together. The refrigerant passes through there and gets compressed in between the blades of that screw. And then the scroll chillers, these are usually fairly small, maybe up to 600 or so kilowatts. They're the least efficient and generally suited for smaller projects, lowest cost. And I'll show you a picture of one of those. So that's a York machine. That looks like it's got 6 scroll compressors. The way these normally work is the compressors turn on and off. So you'd have 6 steps of capacity there, and each step in capacity, another compressor starts. I've got a cutaway of one of those as well. So that's what they look like inside. So we need to select the chiller that best suits the requirements of the project. Determine if a single chiller is suitable, or you may need multiple chillers to achieve the capacity and redundancy. So redundancy is another factor to consider. If you've got a project that has to have cooling all the time, you can't afford to have a maintenance period or you can have a shutdown or a breakdown. The chiller might fail. What happens if it does? You might need to have 2 chillers just to satisfy the redundancy requirement. Okay. Client preferences. Some clients have multiple properties, and they might have a preference for a certain type or manufacturer of chiller based on their experience in other projects. And this happens. They have their favourite chiller. It's our task to advise the client on the suitability of their preferences to the project and present options for their consideration. The technology keeps changing, so they might be used to an old style chiller that, you know, it's been very reliable, but efficiencies have increased, types of chillers have changed, compressors have changed, so there are lots of options available, and we need to find the best option for the project. Obviously, cost is an important factor, but efficiency is very important as well. Refrigerants. Consider the type of refrigerant proposed for the chiller. The different manufacturers will have their selected refrigerant, generally speaking, which may have a limited life. Some chillers are being phased out. Some refrigerants are being phased out to satisfy environmental and safety requirements, such as global warming and energy efficiency. So we need to ensure that the refrigerant will be available for the life of the chiller. Now, I'm not going to mention anything specifically, but HCFCs, for instance, will be phased out in the coming years. Maybe by 2030, you'd have to check. But so there's new refrigerants being developed all the time. They're looking for better efficiencies. You know, it can affect the size of the machines. The machines may get bigger to accommodate a different refrigerant. So all those things need to be looked at. Chiller manufacturer and warranty. The main sources of supply of chillers in Australia are from the USA, Europe, Japan and China. Ensure that the selected chillers are sourced from reputable manufacturers with well-established local service and spare parts support. This is important for the ongoing maintenance of the chiller. Generally, the people who offer you chillers will be well established in Australia, but there are others, and if they're not well established, they don't have a good backup of service and spare parts, then you're probably better not to deal with them. Traditionally, chillers for Australia were sourced from the USA, from major manufacturers like Trane, Carrier and York. These manufacturers still exist and provide a wide range of chillers. They also have plants in other parts of the world. They have factories in France and Italy, for instance, where they make different types of chillers, as well as in the USA. Standard warranty given on chillers is usually 12 months after commissioning, provided the chillers are installed within a reasonable time frame. So if your chiller arrives on site, it gets installed as quickly as you can, and then commissioned in line with the building construction, you'll get 12 months warranty. There are times when construction is delayed for one reason or another, and the chillers might be sitting there uninstalled for 12 months. It could happen. Then the warranty may have to be negotiated because the suppliers might say, look, you've had them too long, they haven't been used, you might have to negotiate an extended warranty. And further extended warranties can be obtained at additional cost with associated requirements for regular maintenance. So in some projects, they might say, we want 5 years warranty on the chillers, and that's not uncommon. And most manufacturers, I'd say probably all manufacturers, will offer you that at a cost. And there'll be a provision that the maintenance has to be carried out by them on a regular basis. So that could be quite a significant cost. But if your client wants that, it's available. They just have to pay for it. Acoustic considerations. We need to assess the noise level of the chillers and their location. Depending on the use of the building and proximity to occupied spaces and or adjacent properties, chiller noise levels can be a critical factor. Air-cooled chillers are typically installed outside and their noise generation can be an issue. In some cases, sound attenuation may be necessary, particularly in the fan discharge. So we might have to put attenuators on the fans. The extra static pressure caused by the attenuators may require upgrading of the condenser fans. This is not unusual. The standard air-cooled chiller might have a propeller type fan, which doesn't really have any external static available or any extra external static. It's been sized to draw the air through the condenser and discharge it, and that's it. If you're going to put an attenuator on, and if the chiller is installed in a plant room, for instance, or an enclosed area where you've got a resistance for the air to be drawn in, then there's extra static, and they probably have to put an axial fan on to get the extra static. And extra static means extra noise, so you've got to account for that. Water-cooled chillers are installed in plant rooms inside the building and are less likely to cause noise issues, but the cooling tower fans can cause the noise issues and they may require attenuation also. So you need to look at the static on the cooling tower fans, and we talked about that last week. Maintenance needs to be considered. And some projects have site personnel employed to carry out maintenance on mechanical plant. Some of those people, you need to understand the capabilities of those people, whether they can look after the chillers. Air-cooled chillers generally require less maintenance than water-cooled chillers. Maintenance costs need to be evaluated over the life of the chillers and included in your life cycle costing. So it might be attractive to buy an air-cooled chiller at the start and say, there you go, there's the cheapest chiller that you can buy. And some people will be happy with that. That's all they want, the cheapest chiller on the market. But you need to look at, well, most projects these days will ask you to look at the life cycle cost. So if the building's going to last 50 years, what's the most economical selection over that time period, for instance? Maintenance of air-cooled chillers applies mainly to the chillers and the pumps. But maintenance cost for water-cooled chillers applies to not only the chillers, but also pumps, cooling towers, and all the associated components with that. Cooling towers have significant maintenance requirements in terms of additional pumps, water treatment controls, and regular cleaning. So all that needs to be factored in to the life cycle costing. Capital and operating costs. Compare the initial costs, capital costs, operating costs, replacement costs, and potential energy savings over the life of the chillers. And when you're looking at life cycle costs, it's, you've got to consider the cooling towers as well, of course, and the maintenance costs involved there. Cooling towers will generally last a long time. I'll talk about air-cooled chillers a bit more in a second. Capital cost of air-cooled chillers is normally less than a water-cooled chiller of the same capacity. May not be, they might be very similar, but air-cooled chillers will typically be much larger, less efficient, noisier, and subject to corrosion from the environment. Expected lifespan of air-cooled chillers is typically much less than water-cooled chillers due to the constant exposure to external weather conditions. So air-cooled chillers, 99% of the time outside the building, probably 100% of the time they should be. But being outside, they are exposed to the weather. In relative terms, and depending on the installation environment, the life expectancy of an air-cooled chiller may only be 10 to 15 years, whereas a water-cooled chiller can last for more than 30 years. And I've seen some chillers still operating that are 50 years old. Granted, they're not as efficient as you can buy these days, but they're still running. So, water-cooled chillers will last longer because they're inside the building. They're built to last. Life expectancy and replacement costs of the chillers must be included when considering life cycle costs. So it's one thing to say to your client, an air-cooled chiller is your cheapest option. And if the client says to you, well, how much will it cost me over the next 20 years? Then you say, well, you may have to replace the air-cooled chillers in that time, but you probably won't need to replace the water-cooled chillers. Okay, so I'm going to save on maintenance costs by using air-cooled, but I'm going to have to replace the chillers in, say, 15 years' time. The answer to that is probably. Okay, so just be aware of that. Site location and ambient conditions. Because air-cooled chillers are located outside the building, they're subject to potential corrosion, particularly in coastal locations and industrial areas. Where there's a bit of salt in the air or acid from industry, air-cooled chillers can corrode quite rapidly. Careful selection of materials is necessary for corrosive environments. So on an air-cooled chiller, for example, the aluminium fins on the condenser coils may corrode quickly. You've got different metals. You've got the copper tubes and aluminium fins on the condenser coils. Differential metals set up corrosion cells. Now, if you've studied a bit of corrosion, you'll understand how that works, the electrolytic process. And because they're outside, they're going to get moisture on them, which encourages this corrosion process to occur, and particularly if there's salt or acid in the air. In order to prolong the life of the condenser coils, we're talking about the fins really. The copper tubes are okay. It's the aluminium fins. The fins can be made from copper, and that's very expensive. You can ask for an option from the suppliers for copper fins, and they'll be happy to give you the option, but it'll cost a lot more. Well, the coils can be coated with a corrosion protection treatment, either in the factory or prior to delivery. Typical protective coatings are, these are brand names, Blygold and Heracite. You'll probably come across those. But there are many other options. So most chiller suppliers will have their preferred coating that they can offer you. And usually they'll include that when they quote you the chiller, because they know that most air-cooled chillers will require a protective coating. Also, air-cooled chillers may not be suitable for locations with high ambient temperatures. The majority of air-cooled chillers will continue to operate above 40 degrees C, but are likely to have derated cooling capacities. So if you've got a situation where, say it's in an environment that has a typical temperature in summer over 40, up to 45, look closely at the ratings on the chillers above 40 degrees. Up to 40, they're probably okay. And they'll give you the full capacity, but above that, they may not. And if you've got an ambient temperature that occurs occasionally, or even quite often at 45 degrees, you need to look at that, because you're going to lose capacity with an air-cooled chiller. Also, they may shut down automatically under their own safety controls. So if the head pressure is going up because of the high ambient temperature, they might just turn off. They won't come back on again until the head pressure drops, and you'll go through the cycle of starting and stopping. So that's a factor to consider. Water-cooled chillers don't have the same problem. The cooling towers will function well in high ambient dry bulb temperatures. In tropical environments with very high wet bulb temperatures, the cooling tower size and efficiency might be a factor to consider. The cooling tower will get bigger because the approach that we talked about last week will increase, the size of the cooling tower will increase, and the efficiency will be reduced. But overall, it's going to keep running. So that might be the deciding factor if you've got high ambience. I've got a few more slides I can show you of different types of chillers. This is a a water-cooled chiller with magnetic bearing compressors. These are centrifugal compressors, and you can see there's 4 compressors there. So you can keep building these chillers up to whatever capacity you want. And I have heard recently that you can get up to 10,000 kilowatts. So they've developed a compressor with each compressor is 1,000 kilowatts capacity. And with 10 of those sitting on top of the machine, you've got 10 megawatts. Make that a bit bigger. This is the magnetic bearing compressor. The motor it's hermetic. The motor's inside there. The refrigerant passes through. These compressors are oil-free, so they're probably the most efficient compressor available because there's no friction. The compressor is running on an air bearing. It's a magnetic bearing. It's not touching anything. It's just floating in the air because of the magnetic field, and there's no oil involved. So these are very popular now. But as I said, the maximum capacity is about 1,000 kilowatts. So you need multiple compressors if you're going to have a large chiller. We've looked at those. As I've said before, you can Google this stuff and have a look online yourself to see what the various options are. This is a Carrier document that gives you a range of chillers they have: water-cooled centrifugal chiller, water-cooled screw chiller with a VSD. VSDs provide better energy efficiency. Water-cooled screw chiller, air-cooled scroll chiller, modular air-cooled scroll chiller. So these can be stacked together to build up the capacity. Air-cooled scroll heat pump, and so on. So you can look these up online if you want to have a look at the options available. Okay, we'll go back on to we'll talk about accessories and options available. As I said earlier, if you're purchasing a chiller from stock, if you've got a small project that needs a chiller up to, say, 400 kilowatts, if you hunt around and talk to the various manufacturers, you might be able to find a chiller that'll do the job if you need a job done in a hurry. A typical application is client wants you to add a chiller to their building, or want their building very quickly. They need a chiller in a hurry. Can you get one in a couple of weeks? You can hunt around and you might find one. I won't say most manufacturers have stock, but I know Carrier usually do. Smart quite often do, because their chillers are built in Australia. So they often build chillers and keep them in stock for smaller projects. So talk to these people and they might have something available. I think Eurothermal is another one who often have stock chillers from overseas. But when you order a chiller, you can ask for numerous options. If you're purchasing a chiller from stock, you won't get the options normally that you might want. But when you order one, you can order any options you like as long as they're available. And here's some examples of typical options. So for water-cooled chillers, you can have one compressor or multiple compressors. So as I said, with a screw or scroll or magnetic bearing compressors, you can have multiple compressors if you need to increase the capacity. You can get heat pump operation, condenser water boxes, standard or marine type. So I'll just look at that a bit closer. So here's that water-cooled chiller we looked at before. This is the condenser heat exchanger. This box on the end here, that's called the water box. The evaporator up here has a water box as well, but normally you don't need to clean the evaporators every 12 months because that's a closed system for the evaporator. The condenser is in an open system, normally, if it's connected to a cooling tower. So every 12 months, they have to take the end off, or the water box, off the condenser. So undo all these nuts and drop it on the floor. It's very heavy. It's made of steel normally, or stainless steel. And they have to clean out the tubes in the condenser. So that's quite a job to do that and to get that off. And they're very heavy to put it on the floor and lift it back and line it up again and put it back on. So you can get what they call a marine water box. In this case, this is the water box here, and it's mounted on a hinge attached to the chiller. So you still have to undo all the nuts, but you can just swing it out of the way, do the cleaning that you need to do inside here, and then just swing it back and bolt it up again. So it's much easier, but it's quite expensive. So typically on a water-cooled chiller, a marine water box, it'll be several $1,000s. It might be 5,000, might be more, depending on the size of the chiller. Condenser water boxes, I'll just go through these one by one. Some manufacturers will offer you a stainless steel water box instead of a carbon steel. Again, you're talking a few $1,000s at least to go to stainless steel, but that might be worthwhile because it's an open system. The water boxes are subject to corrosion. If you use stainless steel, you don't have the same worries. Condenser tube sheet material. The tube sheets are what holds the tubes in place inside the heat exchanger. So you'll have, depending on the size of the condenser, there might be a couple of tube sheets inside just to keep it rigid. And normally they will offer you steel for that. But again, it's an open system. They are subject to corrosion. So you can get stainless steel. You can get epoxy coated steel as well. So there's a few options there. Now, condenser corrosion protection, if you have stainless steel components, you haven't got much to worry about. But if you've got steel, an option could be sacrificial anodes. These can be supplied with the chiller. Or you can get cathodic protection, which is an electronic system which will be supplied probably not by the chiller company, but by another company. Might be the controls company, might offer you that. So keep that in mind. You can get single or dual circuited condensers, particularly with magnetic bearing chillers. Now, this is something to watch out for. If you're looking at magnetic bearing chillers, they can get very high efficiencies, particularly in part load. So it's interesting to compare operating performances at different loadings for these chillers. And if you're looking at magnetic bearing chillers, they'll give you very good efficiency at, say, 50% capacity. So you might be better to run 2 chillers at 50% than run one larger chiller at 100%. You'll get better efficiency. So all these things can be looked at. And a dual circuit condenser means that you have the option of, or with a single condenser, you actually get better efficiency because you've got one very large condenser serving down to, say, one compressor. But in dual circuiting, you've got 2 condensers on the one machine serving one or more compressors. So this is just something to look at for efficiencies because you'll probably find that if you're looking at a magnetic bearing chiller, they'll offer you a single condenser, a single circuit condenser to improve the efficiency. But that may not be what you want for redundancy. So just keep that in mind. You can get direct drive or VSD driven compressors. Magnetic bearing compressors are all VSD driven. They've got an integral VSD. But with other ones, screws and the larger centrifugal compressors, you can get VSDs as an option to improve the efficiency. You may want to put active harmonic filters on the VSD because that can cause problems with the electricity supply. VSD's frequencies can cause some issues. Now, anti-vibration mountings. Generally, chillers are not installed on springs or rubber pads. It depends where they're installed. If they're down in the basement of a building in a plant room, usually not an issue with vibration, but on the roof or somewhere else in the building, you might need to consider it. And if you need to provide seismic mounts, sometimes you need to do that as well. So I've got a couple of pictures. This is a typical sort of chiller installation. It's a centrifugal chiller. It's a little bit hard to see. I'll make it bigger. But this chiller is just sitting on some rubber pads. They're called waffle pads because they're kind of a waffle. They look like a waffle. That's quite often all you do. There's another one here that's got no vibration isolation at all. Again, that's a centrifugal chiller. It's just sitting on the concrete plinth in the plant room. As I said, plant room is probably in the basement of the building or maybe a separate building, and vibration's not an issue there. And these chillers are very well balanced. They don't vibrate basically at all. And the picture of a seismic mount. So if you've got a project that requires seismic mounting of equipment, this is a sample of a seismic mount that would have to go underneath the chiller. These are quite expensive. So, I guess in New Zealand, you're probably used to these, Ilias. I know you have a lot of seismic activity over there. In Australia, it's becoming more common to provide it. So just be careful, that might be required. Okay. Now, other options. Most chillers can be provided with high-level interface to a BMS system. It usually comes at an extra cost and can be a significant cost. So again, we're probably talking thousands of dollars. So just be aware of that. There's an extra cost. We've got evaporator insulation and thickness. So various options here. The evaporator has to be insulated. So the manufacturer, as a standard, will put on the insulation to achieve the MEPS ratings or the NCC requirements. And that might be 25, probably more like 40 mil thick insulation. But you can get thicker if you want that. So you can get 50 mil. You can probably get 75, but normally you might go to 50 mil. Materials available are closed cell material like Armaflex, kind of a rubbery material. That's the standard that they put on evaporators. But you can get polystyrene or possibly polyurethane if you want a higher level resistance. But as a standard, Armaflex is normal, and you can get that sheath as well. So if you want to give that extra protection for the plant room, or if it's outside, They can sheathe that with using metal sheathing, might be Colorbond or just galvanised steel sheathing, as you would for chilled water pipe. And as I said before, you can request extended warranty. They usually give you a warranty up to 5 years, but at significant additional cost. For the air-cooled chillers, again, you can have heat pump operation, the condenser coil materials, copper fins, very expensive, but it's available if you want that, or protective coating. Protective coating is a much less expensive option, and there are some very good coatings which will last for, or extend the chiller life for several years. They won't last forever, but you might get another 5 years out of it. And there can be a maintenance program where you might have a look at that protective coating after 5 years and perhaps reapply it. They do have a minor effect on the heat rejection efficiency. Again, you can have single or dual circuit condensers, particularly for mag bearing chillers. Now, the air-cooled chillers are outside, and if it's in an area that may be prone to hail, hail can do a lot of damage, right? So you can get hail protection on the condensers. So that's a picture there. It's a protective guard over the coil, so that the hail hits the guard, might do some damage to the guard, but doesn't affect the heat exchanger, the condenser on the chiller. So that's something to keep in mind that might be needed, particularly in places like some parts of Queensland. They get hailstorms with very large hail, and they can do a lot of damage. Compressor acoustic enclosure, because the chiller is outside. If you've got a noisy compressor, particularly say a screw compressor, might be a bit noisy. You can get an acoustic enclosure from the manufacturers. It's a standard item that they can put on, but it costs money. So if we look at the air-cooled chiller again, here's the compressor here. It's just like a jacket that goes around the compressor to reduce the noise level. Condenser fan attenuators. The attenuators won't be supplied by the chiller manufacturer. They'll come from an attenuator supplier, but the static pressure upgrade, you'll need to request that from the chiller supplier. So you might need to go to an axial fan instead of a propeller fan to get the extra static. That's quite common because they do make a bit of noise. You can get corrosion protection on the frame. So corrosion protection painting, for instance, or get the frame, well, the frame will be galvanised anyway, no doubt. So you can get extra coatings on top of that. Direct drive or VSD driven compressors again. So these are the same sorts of options now as water-cooled. Active harmonic filters on the VSDs. Anti-vibration mountings. Now the chillers, air-cooled chillers will normally be installed on the roof. So you might need to think about vibration isolation in this case, if it's a tall building. So again, rubber pads might suffice, or springs or seismic springs. The magnetic bearing chillers are extremely well balanced and vibration free. And some people had their doubts about this, but I have experienced myself. We worked on a project that needed very tight vibration control, and but they wanted to use an air-cooled chiller. Their preference was magnetic bearing chiller, and there was on this particular project there was actually noise and vibration consultant, and he said he wanted the chiller on springs. We tested the chiller in the factory without springs, and a representative of the acoustic company came out with an accelerometer, which is used for measuring vibration, and they couldn't detect any vibration at all. So in the end, we were able to install a chiller without springs on a very vibration sensitive project. So that was quite impressive. I was surprised myself, but we found that out. The manufacturers were saying there's no vibration, and even some of the big centrifugal chillers, they'll put a coin on its side on the compressor, and the coin doesn't move. It's pretty impressive when you can do that. So vibration is minimal with these compressors. Again, we've got options for high level or low level interfaces, evaporator type and thickness and sheathing, and extended warranty. So to conclude all of that, when all the selection factors have been considered and all the necessary information has been gathered, an informed decision can be made regarding the most suitable chiller for a project. The chillers are likely to be the most expensive part of the HVAC system and the highest user of energy. So the chiller selection will have a significant impact on initial project costs, ongoing energy costs, and long-term project costs. They're the major factors to consider. There are more factors, but hopefully that gives you a bit of an idea of the things to look out for when you're looking at chillers, and it's not just not always just a simple matter of saying I'll have that one, because there's plenty of others that may be more suitable for the project. Well, we've just about run out of time again. Any questions?
Yeah, I've got a question. Oh, actually, I've got two questions. One regarding to phase out refrigerant. Whose responsibility is that once we send specification to a supplier saying we need this lifetime, and then they supply a chiller with a phase out refrigerant?
Well, if that's a major issue, if it's going to, like if you go for water cooled chiller, for instance, and the refrigerant is going to be phased out in 2030.
Yeah.
I think you'd have to say that that's not a suitable selection for that project. So you'd have to look for an alternative selection with a refrigerant that's going to, well, at this stage, not be phased out, such as a like a.
Yeah, but shouldn't they coat that chiller at all?
Probably not now. If it's going to be phased out in 2030, they probably shouldn't. I know that one particular manufacturer, I won't mention any names, but they used a refrigerant which was a very efficient refrigerant, very energy efficient, but it was it's a HCFC, hydrochlorofluorocarbon, I think that's what it is. That will be phased out. So they've changed now, and they've changed to a new refrigerant which is going to have a long life and has a very low impact on the environment. So they are aware of it. It's not as if they're not aware of these things, but it's just something that we need to be aware of, to have a look at it, make sure that it is going to last a long time. It's kind of a shared responsibility, but the manufacturers are doing everything they can to change refrigerants. Yeah, you can imagine, a manufacturer invests a lot of money in developing their products, and then suddenly, we have to change. So it's a big cost for them. But they are working on it. Did you have another question?
Yeah, another question is about sacrificial anode. Is there a specific reason why it is optional? If it's mild still in the system, wouldn't it be wise to make it not optional, and then, hey, it's going to corrode no matter what?
Yeah, well, I suppose from the manufacturer's point of view, you might be using a fluid cooler, a closed system. They don't know that. That's not what they do. So they might say, well, we're going to give you a standard steel marine box. Sorry, standard marine water box.
Yeah.
It's up to you protect that from corrosion. Now, you can use a fluid cooler, which is a closed system, and your condenser's fine. But if you're going to use an open system with a cooling tower, then you need to consider corrosion. So they offer that as an option because that's up to you to decide what you need. So you can buy a water box with provision to put in a sacrificial anode. That's unusual. Usually they go for cathodic protection, which is the electronic type, and they have to put a few points around the water box for the probes, the sensors to go into, and that can be quite expensive. But they don't. I don't think you'll find anyone who offers that as a standard option because it's a very competitive market like everything else. If they keep adding options for nothing, then, or included in the cost, then they're probably going to miss out on the order. So we have to order those things.
Okay.
Anything else? No other questions? Okay, got a thumbs up there from Stephen. All good. All right, well, thanks for your attendance, and hopefully we'll see you again next week.
Yep.
Next week we're going to
Yeah,
talk
thanks.
about air handling units.